Dear student, as I already told you that in raster graphics line drawing, we will discuss two famous algorithms that are digital differential analyzer and Brazenham algorithm. So first of all, we will discuss digital differential analyzing line drawing algorithm. The steps of the algorithm are given on the slide. You can see the step 1 is walk through the line starting at x0, y0. These are the starting points of the line. Next, in step 2, the constraint need to be followed for x and y in order to increment their values if they are within the range of 0, 1. Based on step 2 condition, we have two different cases. The first case at step 3 is x is incrementing faster if f slope is less than 1, that is m is less than 1. Then increment in x, compute and round y. The second case at step 4, y is incrementing faster if the slope is greater than 1, that is m is greater than 1. Then step in y is equal to 1, increments, compute and round x. In the figure below at the right side, you will see the algorithmic conditions are depicted when the slope is greater than 1, equal than 1 and less than 1. That is m greater than 1, m is equal to 1 and m less than 1. First case, that is m less than 1, is depicted pictorially on the slide. The starting point of the line x0, y0 is assigned to x is equal to x0 and y is equal to y0 for calculating the value of x and y in order to determine which intermediate pixels become on so as to complete the slopy line. The calculations are reflected on the grid at the left side, and the intermediate on pixels in blue squares, whereas the starting and ending point of the line is shown in white rectangles. This is how case first, m less equal 1, is accomplished. Now we will discuss case B when slope greater than 1, that is m greater than 1. It is also depicted pictorially on the slide. The starting of computation is same, that the starting point of the line, that is x0, y0, is assigned to x is equal to x0, y is equal to y0. The whole computation for this case is the inverse of the previous case, and the slope is taken as denominator in order to calculate the value of x. The output of the whole computation is shown in the grid at the left side of the figure, whereas white squares shows the starting and ending point of the line and blue squares represents the intermediate on pixel in order to complete the line, which are the result of the computation when the slope m is greater than 1. Dear students, as DDA is the simplest line drawing algorithm, therefore it is not very efficient and expensive in terms of round operations. Therefore, we required optimized algorithms like integer DDA or Brazenham algorithms, which is an advanced form of integer DDA. Brazenham algorithm is considered to be very efficient for line drawing and covers all drawbacks of DDA because it is an incremental algorithm, means the current value uses previous values. Moreover, floating point values are discarded in this algorithm, means only integers are used and there is no need for round operation. Based on the flexibilities, Brazenham algorithms has several versions of algorithms. Here we will describe midpoint version of the algorithm in the next part of this lecture.